Okay, welcome students. It's Mr. Green. Sorry, I'm still not there. I'm still getting over my sickness. What I'm going to do here is I've recorded a short little video going over Vertex Forum Day 2. This stuff isn't too difficult. It's pretty similar to what we've done in Vertex Forum Day 1. So that's why I feel comfortable doing it this way. What you will need to do is you will need to take notes on this on your paper and follow along with me. You will turn in your notes at the end of class to the basket. You will need to turn those in so that I know you were following along during class. I will give those notes back to you once I get back in class, which will probably be the beginning of next week, okay? So let's go ahead and dive into it. Once we're done with this, you'll have some time to work on the homework for Vertex Forum Day 2 and Day 1 if you haven't done it yet. What we're going to do today is looking at converting to vertex form again, only we are going to add a slight twist to what we're doing today from what we did last time, which is we're going to be doing it when maybe there's more than one x squared, okay? So maybe a isn't 1 for the ones we're doing today. But before we dive into the new ones, let's just review real fast how we kind of see vertex form and standard form using our algebra tiles. Okay, so let's look at, we have here some algebra tiles over on the side of number 1. Remember this big square right here, that represents x squared, okay? So the standard form will start with just an x squared in there, right? Now remember, these long skinny ones, those represented x. Sorry, I'm not used to writing on my tablet. Okay, so those just represent x. So how many x's do we have? We're going to have 4x. And then the number at the end comes from these little ones over here, which each of those has an area of 1. So there's 1, 2, 3, 4, 5, 6. So there's going to be 6. Maybe I'll change colors so that we can see where that's coming from. Okay, so 6 little ones, and that's my standard form, x squared plus 4x plus 6, okay? Now, the vertex form takes a slightly different approach of writing the equation. So if you kind of remember, I'm going to just erase this real fast. Okay. The vertex form is looking at this square. Oops. Need my writing stick on again. Okay. We're looking at that square and we're finding the area of the whole thing. So the area of it, remember the side here is x, and then the little sides are 1. So the whole side there is x plus 2. You kind of put 2 x tiles on each side of this. So your vertex form is going to be x plus 2 squared. And then on the outside of that, okay, notice not everything is in the square. There's a little bit of leftover here on the outside. There is plus 2 on the outside, okay? So these two equations are the same thing, right? They're just different ways of writing the same thing. They both represent this area over here, okay? Now, on your notes, I just need to make sure that you get those formulas down. So I'll just leave these up for a couple seconds here, and then we'll move on to the next one, okay? Okay, let's move on. Okay, so number 2, This is an example of the new thing today. You'll notice we're now combining. I have two different squares in this one, and then we also have a little bit of leftover on the side here, okay? So that's kind of the new thing. I've got two squares going on here. Let's start with the standard form. So I've got an x squared here, and x squared here. So there's going to be 2x squareds, okay? Then we have an x, an x, an x. So there's 3 x's there, and then another 3 x's on this side. So that's going to be 6x. But then we also have the x's on this other square. So that would be, there's 3 more, so 9, and then 3 more. So there's a total of 12 x's, right? Because there's 3 on each side. We've got 4 groups of 3, so that's going to be 12 x's, okay? Now we can just count out our ones. So our ones are these little ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 in that corner, which means there's also 9 over here. So that's 18. And then there's one more over here. So 19. So 2x squared plus 12x plus 19 is all of the stuff we have going on here, okay? Now, the new idea today is, how do we write this in vertex form? Because I've actually got 2 squares, okay? 2 squares, and they're both x plus 1, 2, and 3. So it's x plus 3 squares that we have. So how you're going to write this in vertex form? I'm going to scroll just a little bit so you can see that would be x plus 3 squared. That's the area of one of these squares, okay? But then there's another one. So how we do that is there's 2 x plus 3 squares, okay? And then my number on the outside, that covers the 2 squares. My number on the outside is over there, which is just 1, okay? So notice you can still do vertex form. You're just going to put a little number out here for how many squares that you're doing, okay? So what's different about this one than the one we did at the beginning? Well, number 2 had 2 squares in it, right? Instead of the one big square, okay? So when you're dealing with more than one square, you're just going to throw that number out in the front, okay? So I'll leave this up for just a second here. So if you need to write this down, you can. But then we'll move on. Okay. Let's go ahead and move on here. So I think that's it for that page. So let's go ahead and move on to our next page. Okay. So this is another example. This time, how many big squares do we have in our form? Well, this time there's actually 3 of these big squares, right? So this one, instead of having 2 squares, we've got 3, okay? Let's find the standard form first, and then we'll find the vertex form. So standard form, we'd have 1, 2, 3 x squared. So 3x squared. Then x's, I've got 1 here, 1 here. So that's 2 x's, so 2. Then 3, then 4, 5, and 6. So that's 6 x's, okay? And then in the corners, I've got my 1s. So I've got 1, 2, 3, 4, 5, right? There's 3 in the corners and then 2 on the outside. So that's going to be plus 5. Okay, 3x squared plus 6x plus 5. Okay, that's standard form. Now let's do the vertex form. How we're going to do that is I'm going to look at one of my squares and figure out what type of square it is. Well, this side is x, that side is 1. So it's going to be x plus 1 squares that we're dealing with, okay? Each one of them is an x plus 1 square, okay? How many x plus 1 squares do we have here? Well, there's 3 x plus 1 squares, and then there are just 2 left over on the outside. So I'm just going to do 2 on the outside, okay? So the fact that there's 3 is giving me that 3 out in the front, and then the x plus 1, this one side right here, that's what's giving us the 1 that goes right there, okay? And this would be our vertex form. Okay, I'm going to leave this up for just a second. If you need to write down your equations, go ahead and do so. Okay. Now let's kind of go backwards. So this time it's going to give us the equation in vertex form. And now we're going to write it out in standard form, and we're going to draw a picture. So we're going to start with we have x plus 1 squared. So I'm going to have an x plus 1 squared. So to get an x plus 1, I'm going to need an x tile, an x distance, and then we're going to need to put 1 additional x on each side, right? So 1 and 1, this would be x plus 1 and x plus 1. We just need 1 in the corner to fill it in, right? So it would be x plus 1 squared would be that area, okay? But notice on this one, I have a 2 out front, which means I need 2 of these squares, okay? So I'm going to do the exact same thing over again. We're going to do x plus 1, x plus 1, and we're going to fill in that corner, okay? So there's 2 of these squares, right? So I've got 2 of them. Then the last thing we haven't dealt with yet is this 3, right? The 3 means I have 3 leftovers. So what I'm going to do is just put 3 of my little ones on the outside. The area of all 3 of these, gives us 2x plus 1 squared and then plus 3. Okay? So what would our standard form be? Go ahead and take a second and try and figure it out. Okay, I'll give you just 2 more seconds on that. Okay, let's look at it. So, for standard form, I'm going to have an x squared here and x squared here. So it's going to be two x squareds, right? Because I've got two of them. Then how many x's did we have? That was the long skinny ones. Here, 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 and here. So it would be 4 x's. And then in the corner, we've got a 1 here, a 1 here, and then we've got 3 more, right? So I've got 2 plus 3 is 5. Okay, so 2x squared plus 4x plus 5 is another way of writing this quadratic equation. Okay. Okay, so I'll just leave this up for a couple seconds and then we're going to move on here. Okay. Okay, let's go ahead and move on. We're going to flip over to our next page. Okay. So, what we're going to do now is we're going to do actually converting something with more than 1x squared into vertex form. And we're going to use our algebra tiles to do that, okay? And this is kind of the important point for today. And this is what most of your homework will be about here, okay? So, what we're going to do is we want to put it in vertex form. So we're going to try and make squares. Now, where we have a 3x squared, that's going to give me 3 of these x squared squares, okay? Of these x by x squares, okay? What we're going to do is we're going to make 3 perfect squares on this one, okay? Now you'll notice to make our squares, we have 6x in the middle. So that means I've got 6 of these long skinny ones. So 1, 2, 3, 4, 5, 6 of the long skinny ones that I've got to place between these 3 squares and get 3 perfect squares, okay? So what we're going to do is we're going to look at first to make all the squares be the same. What I'm going to do is first divide my 6 squares, or sorry, my 6 x's into 3 equal pieces because I have 3 equal squares that I want to make. So that would give me 2 x tiles per square, okay? Which means I've got to put 2 on the first square, 2 on the second square, and 2 on the third square, okay? That will give me a total of 6. Now, how do I actually make a square with those 2? I'm going to put 1 on each side. I'm then going to take those and divide it in half, okay? So I'm putting 1 on each side here, dividing it into 2 equal pieces, okay? So that will make us 3 equal squares. Now we just have to figure out how many we need to go in my corners to fill in my squares. So I need 1 here, right? Because it's 1 by 1. We need 1 here, and we need 1 here, okay? Now notice on this one, we started with 8, right? To fill in my corners, we had 3 that are taken to fill in the corners. So then that means I'm going to be left with 5 of these little ones on the outside, okay? So now that we kind of have this picture, let's go ahead and write this in vertex form. The vertex form is going to be, I'm going to look at each square. It's x plus 1 on this one. So it would be x plus 1 squared, okay, because they're each x plus 1 squares. How many of them do I have? Well, I have 1, 2, and 3 of those squares, right? So I'm going to put a 3 out in the front, okay? And then how many extras do I have on the outside? It was 5. So this is how you write this in vertex form. Okay. Let's do another one to make sure we get this, okay? But I'm going to leave this up for a second, so if you need to take notes, you can. Okay, let's go ahead and move on here. Let's do the same thing with this one, okay? So, what we're going to do is complete the square, and this time, how many squares are we going to make? Well, it's 2x squared, so we're going to make 2 squares, okay? Now, what we're going to do is we're going to divide the 8x, and I'm not going to draw them all just for sake of time. We've got 8 x's on this one. Those are the long, skinny ones like that, right? I'm going to divide those up between the 2 squares that I have. So I'm going to do 8 divided by 2 because I have 2 squares, telling me I need to put 4 x's on each square, okay? So I'm going to put 4 on each square. And 4 on this one. Sorry, I'm not drawing these the best. Like that. Okay. So I'll put 4 on each. Now I can look at how do I make a square with these 4 x's that we have here. Well, I'm going to need to put 2 on each side. And actually, I think I'm going to erase those down there just so that they don't get in the way. So I had 4 going to each square, which means now I'm going to take my 4 and divide that by 2 to figure out how many go on each side. So we're going to put 2 on each side in our square. And again, I'm going to erase these guys right here. Oopsies. Okay. I'm not a very good artist, as you can see, but we're trying. Oops. So there's 2 x's on each side. Notice, does that give me the right number of x's? I get 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8 x's, okay? And we have them divided evenly, so we're getting perfect squares, okay? Now let's figure out how many we need to fill in these corners to make perfect squares, right? Well, if we draw in our lines, it is just going to be 2 by 2 would be 4 to fill in my corner, right? And same thing for this one. It's going to be 2 by 2 would be 4 to fill in the corner, okay? So in total on this one, I need 8 to fill in the corner. And I had 1 to begin with, right? So to figure out how many I'm going to need in my vertex form, notice I'm short on this one, right? So the end of my equation is actually going to be a negative number. How many are we short? We're actually short 7, okay? So let's write our vertex form. It's going to be x with something squared, okay? So the number that goes inside this square here, that's how many x's we put on each side. So there's 1 and 1. So I'm going to put x plus 2 squared because of putting the 2 x's on the side, right? So x plus 2 squared. Then the thing that goes out here, that's how many squares we made. So we made 2 squares, okay? That was 2 squares, x plus 2 squares, okay? And then the last thing is how much leftover did we have? Well, this time we didn't have leftover. We were short 7. And so our vertex form would be 2 times x plus 2 squared, and then minus 7. Okay? Okay. We're probably not going to do all of this packet here today just for sake of time, because I know it can be hard to listen to a video for super long. So what we're going to do is I'm going to do number 8 here. These will be the last ones that we do. But you should have everything you need to do the homework after we do these ones, okay? Now, number 8 is not asking us to write it in vertex form. It's just asking us to find what number we need to put here so that we get a perfect square, or really a combination of perfect squares. How many we would need to fill in the corners, okay? So let's draw a picture of this. We'll kind of just do a quick practice here. I have a 2x squared, so that's going to give me 2 x squared tiles, okay? 12 x's, so what I'm going to do is I'm going to take my 12 and divide it by 2. That's how many x's per square. So we're putting 6 x's on each square. But then I need to divide that between the 2 sides of each square. So what I'm going to do is do 6 divided by 2 again, and I'm going to put 3 on each side of my square. So 1, 2, 3. Oops, we'll say that that's 3 over there. That's supposed to be 3, even though it doesn't look like it. Drawing is hard on this tablet. Sorry, guys. Okay, notice, is that the right amount of x's? I have 3 and 3 on this one. So 3 here and 3 here. That's 6. And then we've got 3 here and 3 here. So 6, so 12 total. And that's correct, okay? How many do we need in this corner and this corner to make it work? Well, each corner is 3 by 3. So it's going to be 9. And then this corner is also 3 by 3, would give you 9. So how many do we need to fill in the corners to make this be a perfect square? It would be 18. Okay, 9 plus 9. We had 2 groups of 9. Would give me 18. Okay, go ahead and try that last one. I'll give you guys just a minute to think about that last one. Okay, start wrapping up what you're working on. Okay, let's go ahead and look at this one. So we've got 3x squared plus 24x. How many squares are we going to make on this one? There's going to be 3 squares, okay? So I'm going to take my 24 and 24 x's and divide it by 3. So that means each square gets 8 x's, okay? Then once I do that, I can divide my 8 by 2, okay, to get how many need to go on each side, which would be 4 for us. So basically, we're going to need 4. That does not look pretty. So 1, 2, 3, 4. We're putting 4 on each side. Okay? To figure out what goes in the corner, whoops. This is not looking pretty for me. To figure out what goes in that corner, it's just going to be 4 times 4 is 16. Now, all of the other squares will also have that same amount in them, right? So I have 3 of those. So 3 times 16. That is a little nasty, isn't it? It's 3 times 16 would be 48, I believe. Okay. That's the number of squares you need to make a perfect square there. Well, actually 3 perfect squares, right? Okay, so on the homework for today, what you're going to be doing is converting to vertex form and then also just finding the number that you need to make a perfect square, okay? So the rest of the time today, you have to work on the vertex form, day 1 and day 2 homeworks. Go ahead and work on that and make sure you turn in your notes at the end of class.